Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will discuss about the process parameter of friction stir, or you can say FSW process. So in friction stir welding process, the most important part is material movement and is plastic deformation. This you should keep it in mind. So this material movement, which is highly depends on plastic deformation of the material, definitely. So depending upon this flow pattern and plastic deformation, the quality of weld is dependent. Now this material movement and this plastic deformation highly depends on different types of parameters. Here I am showing some most important different types of parameters which generally affect this flow pattern and its plastic deformation significantly. Here I am showing around 9 different parameters which commonly have a significant effect on this weld quality of friction stir welding process, that I am showing. So you see, these are the operating parameter or process parameter. Like that most important parameter is tool rotational speed, another one is called tool transverse speed, that means welding speed, then another one is called tool tilt angle and tool plunge depth, another one is called tool plunging force, then tool geometry, tool shoulder diameter, pin length and pin geometry. These are the very important parameter which affect the material flow and its material joint quality of this FSW process significantly. This you should keep it in mind. So here I have used some terminology that you should know. What is this terminology? Okay. Now here you see like plunge depth, what is called plunging force, this you should know. Generally in FSW process, let's this two workpiece which we are connected by a tool, this is the tool, okay, this tool have a pin, this tool have a pin, okay, you see like this. So you see, now this tool pin height means what happens from this shoulder surface. Here in first figure I am showing, this is shoulder surface to tip surface, tip of this pin is called pin depth. What it's called? Pin depth. Now always keep this thing in mind, this pin depth should be little bit lesser than the plate thickness. Whatever the T we are using, let the thickness of the plate is T. So let this depth of the plate I am representing as a small d. Always keep this thing in mind, this d should less than T. So what is the range of this lesser size of this d? It is generally within a range of just here I am writing around 0.2 to 0.3 millimeter, or some cases it can be 0.5 millimeter, 0.2 to 0.3 millimeter lesser than the thickness of the plate. Now to make proper contact, generally to make proper contact this workpiece, generally some impression of this tool shoulder, that means some penetration of the tool shoulder sometimes required over the surface of this plate. So some sort of penetration of tool shoulder also taken place through this thickness direction of this workpiece material, that is called plunge depth. Here you see, this is called plunge depth, and that means some portion of tool shoulder enter into the workpiece material. This is called plunge depth. You can write PD here, PD I am writing PD. What is plunging force? You see, this is the most important force. Plunging force means what happens? Vertical force which is acting on the tool which is perpendicular to the plate surface, that you can observe. This is called plunging force. Depending upon this plunging force, generally what happens? This is a normal force. This what it's called frictional heat is generated. Okay. So once you see what are the different force acting in a friction stir welding process, this you should know little bit. Here you see, in a friction stir welding process there can be different types of force. One is called plunging force, another force can be once it motion, that means once it is moving along the direction of welding. So, during that time generally you will get a thrust types of force which oppose the motion of this tool. So, that is called linear types of force, or you can say longitudinal force which is acting along the direction of the welding. So, longitudinal force, like what happens, let this is the plate, let this is the plate. So, let this is the impression of the tool. So, this is plunge force which is normal direction, another one force which is acting, let this is the welding direction, this is the welding direction, this is called linear force, linear force, or you can say it is welding direction force. Another force is acting generally lateral direction of this tool, it is called lateral force, and another force is acting in this tool, FSW tool, due to rotation of this tool, that is actually not a force, that is called torque. What I am telling, understand, torque. So, these are the different types of force and torque acting in a FSW tool, this you should keep it in mind. So, the main important force is generally this plunging force, and another one important parameter of this friction stir welding process is generally called torque. Okay. This torque is coming due to this rotation and this movement of this rotating tool. Due to rotation there is occurs some torque. Okay. Now, this is the setup of FSW process, friction stir welding process. Here I am showing the actual setup. Here this FSW tool, here you see this is the FSW tool, you can see in right side figure I am showing, this is the tool which tool holder. With this tool holder generally a FSW tool, here you see I have written in front of this tool holder we attached a FSW tool. So, first and foremost component of a FSW process is FSW tool, then tool holder. This tool holder is connected with a rotating arm. This rotating arm can be different types. This can be a robotic arm, this can be a vertical milling machine arm, what I am telling, understand. So, depending upon the requirement we can have different types of this rotating arm. Now, to hold this workpiece firmly there is required a what is called clamping or holding fixture. So, you see this is called fixture, here you can see actually a fixture is designed which is generally firmly combine the two workpiece material here. Now, here you see there can be a backing plate at the bottom side of this plate, there is a supporting plate is there, that is called backing plate. Now, if we are going for measuring this force and torque, there is used a dynamometer system. Here you see this yellow color represent a dynamometer. By this generally we can measure the what it is called, we can measure the torque as well as different types of force component, that means plunging force. Now, these are the different types of friction stir welding joint. So, by friction stir welding process we can join different types of combination of material, like this can be joined to horizontal workpiece together. Here we can do butt welds, here we can do overlap types of welding process, here we can do corner types of joint, here we can do T types of joint. Here you see how it is made, that you can observe here. So, this is generally T joint we make, this is FSW tool, this is corner FSW tool, and this is the corner joint we can make by this configuration. Then another things also we can do by friction stir welding process, that is called friction stir spot welding. Friction stir spot welding means, let this is one workpiece, this is another workpiece. So, what happens? So, in this location we can make a spot types of weld by using FSW process, friction stir welding process. So, here generally this is the tool pin, this is the tool pin which penetrate inside this region. So, due to these things what happens at same location, if it is rotated for a particular time, there can occur a spot types of weld. So, this is called friction stir spot weld. Now we will discuss about different variant of this friction stir welding process. So one of the categories of this thing is called self-reacting friction stir welding process. Self-reacting friction stir welding process. What is called self-reacting friction stir welding process? That I will discuss in subsequent slide in details. So you see, this is the self-reacting friction stir welding process. This process can have two different categories. One is called bobbin tool types of self-reacting friction stir welding process. Another one is called adaptive technique friction stir welding process. Now this bobbin tool, how it's look like, here you see in the second figure, you see here I have shown a bobbin tool which have two solder. This is one solder, this is another solder. This upper solder is called upper solder, lower solder is called lower solder. This two solder is connected by a pin in between. Okay, this you can see. This pin, so the gap between these two solder, you see, so this is one solder, this is another solder. So this two solder is connected by a tool pin. So this is upper solder. This is lower solder, correct? This is lower solder. So this is called tool pin. Now here one thing you should keep it in mind, this is called bobbin tool. Now this bobbin tool, this lower solder diameter little bit lesser than this upper solder diameter, this you should keep it in mind. Whatever the diameter of this lower solder, this is little bit lesser than upper solder diameter. So depending upon this thickness of the material, the gap between these two solder we have to decide. This gap between two solder is we have to decide. So this is, let's give the gap between these two solder, this is decided. Why it is called self-reacting types of force, that also you should keep it in mind. Here you see, this is one solder, this is one solder, and this is another solder, top side this is another solder. So here there is a tool pin. So what happens due to this rotation, this is a combined tool, this is rotated like this tool is rotated like this. What happens here, the material becomes soft enough and material have a motion here. Due to this motion of this material, what happens here occurs some sort of reaction force. This reaction force generated due to this movement of this tool rotation, and what happens, softening of the material and its material movement. So as this force is developed which act to the tool solder surface due to self effect, that means self effect in the sense this motion of this workpiece material inside, that is why what happens, this is called self reacting, that means this is a reaction force which is created in the weld zone and its act on the solder surface of this bobbin tool. What I am telling, understand, that is why it is called self-reacting types of friction stir welding process. Whereas adaptive techniques, this adaptive techniques is such a technique, this technique generally enables adjustment of the gap between the solder during the welding operation itself. But in bobbin tool, this gap is fixed, whereas in adaptive type of self-reacting friction stir welding process, this tool can adjust its gap in between two solder. This you should keep it in mind. So it automatically adjusts as per our required thickness of the workpiece. This is called adaptive self-reacting friction stir welding process. Okay. Here one thing you should keep it in mind. This weld essentially eliminate partial penetration, lack of penetration or root defect, and what happens in this process throughout the thickness of the weld region, more or less uniform nugget zone we can get. That means throughout the entire thickness, this thermal gradient here is less, you can say. This shape of this thermal or you can say weld nugget zone is saddle in nature, saddle types of shape. That is why what happens in these types of welding process, we can get lesser type of deformation compared to other friction stir welding process. Okay, this you should keep it in mind. Now hybrid friction stir welding process, here you see it is a joining process which is generally done by preheating the high melting point material ahead of the FSW tool, and it's enhance the material flow to improve the weld quality. So hybrid, what I have already told you, the hybrid welding technique, here a secondary technique is used to improve the material movement or material flow, you can say. So, this hybrid technique can be done by some arc types of heating, it can be done by some electrical means, it can be done by some ultrasonic vibration means, it can be done laser types of heating. So, depending upon this assisted mechanism, it has different types of name, what I am telling, understand. So, here in case of dissimilar types of joint, the additional heat source generally should be located in harder material side to provide adequate material flow around the tool. So, if we use this additional heat source and if we just soften the material beforehand, then what happens, this tool plunging force as well as this tool pin wire, which is a very critical phenomena nowadays for high melting point alloy, that we can minimize. Actually, we cannot eliminate fully, but we can minimize by some extent. So, we can increase the tool life of this process, that means which is the most important part of friction stir welding process, this FSW tool life, because what happens once this FSW tool pin will break, or if it will be wire more, then what happens is tool life decrease drastically, correct. Then what happens, this process will not be effective one. So, to improve the tool life and generally to make the process more easy, you can say, for high melting point alloy, generally this hybrid welding techniques is popularly used, because once we use the additional preheating types of mechanism or additional types of mechanism to soften the material beforehand, then what happens, we can reduce this plunging force of this FSW tool, because what happens as due to the preheating, this FSW this workpiece material will be softened enough initially, after that it will penetrate, then what happens, this tool plunging force as well as this tool pin wire and shoulder surface wire, it will be reduced. That is why what I have told you, it has lot of benefit over conventional friction stir welding process, like it reduce FSW tool wear, it reduce plunging force, it improve the weld quality, and another thing, as the faster and better plasticization is taken place of the base material, that is why what happens, here you can show we can speed up the process rapidly than conventional FSW process. And due to this preheating, it also prevent the formation of brittle intermetallic compound, that it cannot fully eliminate, but what happens, it somehow some short it decrease this formation of brittle intermetallic compound for dissimilar types of material joint. This you should keep it in mind. Now, this plasma assisted friction stir welding process, here you see a plasma torch, in the first figure you can see a plasma torch which is used just ahead of this FSW tool. So, which initially heated this ahead portion of this joining region. So, after that, as this tool is moving, that is why what happens, due to this preheating of this plasma heat source, this material will be soft enough. So, what happens, this FSW tool will pass through a softer region, comparatively softer region. That is why what happens, in that FSW tool, there will be lesser wear, there will be lesser tool degradation, what I am telling, and there we can reduce this downward force, or you can say plunging force. So, from our research work, it is observed that by using this plasma assisted friction stir welding process, we can reduce around 20% of the original plunging force for conventional friction stir welding process. That means 20% force is a very high amount of plunging force. So, due to these things, lot of effect related to this plunging force, like tool wear, tool life. So, these are the things we can significantly improve. Now, induction assisted friction stir welding process, here is used a induction coil. You see, this is a induction coil, you can see in this first figure, here you see this is the first figure, this is a induction coil. Through this induction coil, generally once we supply this alternating current, due to this induction coil, so a magnetic field is generated here. So, due to this magnetic field, and as the alternating current is passing through this coil, there will be a fluctuation of this magnetic field. Now, we know once there is a fluctuation of magnetic field, according to Faraday's law, we know there will be develop a eddy current, correct. Now, this eddy current once is passed through this workpiece zone, then as workpiece have some resistance, that is why what happens, once current pass through this resistance, there will develop some heat. That is very well known to you, because let this workpiece have a resistance R, let us I am just telling, and then let the eddy current required is I. So, we know this heat energy is will be your I square R into T time, correct. This is in joule, because we know how this I square RT is coming, that is very well known to you. Know, we know that power due to this current flow is V into I. So, this V again we know this V equal to I into R. So, if we just put these things, we can get I square R, this unit is watt. Now, what happens if it will be in a particular time, then Q into T, Q into time represent the heat. So, this is in joule, that you can easily observe from this figure. So, due to these things, you see, due to this induction coil, how the plate is heating, red heating, you can observe in second figure. This is a induction coil setup. Here you got the idea, here due to eddy current generally this heating is done. So, once you use this preheating source ahead of this FSW tool, this is the FSW tool, this is the tool FSW tool, and this is the induction coil. So, ahead of the tool once you use, so beforehand our material will be soft enough, then this FSW tool will pass through a softer region. So, FSW tool wire as well as FSW tool degradation will be less and its life will increase. This you should keep it in mind. There can be some other hybrid FSW process, like it can be arc assisted. This arc assisted means some other arc assisted, like we can use TIG arc, tungsten inert gas arc as a preheating source. We can use a laser assisted friction stir welding process, there is used a laser preheating source. We can use a electrically assisted friction stir welding. Electrically assisted friction stir welding process means here instead of using a preheat source, here we are making our workpiece as a part of this circuit system. So, once the current pass through this workpiece, then what happens, our workpiece will be resistance heating, or in workpiece resistance heating will be taken place. By some electrical current passing through the workpiece, we can heat the workpiece beforehand. Okay. Another process is called ultrasonic friction stir welding process. Here high frequency vibration such as ultrasonic vibration, or you can say ultrasonic types of system are used, which are superimposed on a static load to soften the metallic material without significant heating. Because once we use a ultrasonic vibration on workpiece material, then what happens, there can be generally what happens, this plunging force and other things we can significantly reduce, because this vibration once we superimpose with this static loading, then what happens, sufficient heating can be done. This is called ultrasonic assisted friction stir welding, where ultrasonic vibration is used to improve the heating system. Okay. Now, underwater friction stir welding process, here then this friction stir welding process is carried out underwater. That means a chamber generally developed, inside this chamber generally all fixture, then workpiece material is kept. After that water is patching, or water generally fill this container. Okay. So, this is the water inlet pipe, this is water inlet pipe, this is outlet pipe, through this generally water circulation is taken place, and this is FSW tool, and this container is filled with water. So, this workpiece material is submerged under this water, this you should keep it in mind. So, this full welding process is taken place, that means tool as well as workpiece welding zone is under the water. That is why what happens in this process, we can maintain a low heat input as well as we can have a constant heat input along the weld line, which create fine grain microstructure in TMAZ zone as well as heat affected zone, which leads to improve the joint property significantly. This you should keep it in mind. That is why here I have written, there are different types of benefit of this underwater friction stir welding process, which is short form, it is represented UFSW. Like what happens, the benefits are like it generally refine the grain structure due to this underwater heating. It has less welding defect, it has less intermetallic compound, it reduce residual stresses, and also it creates less distortion. Okay. It has better surface appearance of welding, grain coarsening also can be controlled here. Okay. Now twin or you can say twin stir friction stir welding process is nowadays is very popular friction stir welding process. This twin stir friction stir welding process have 3 different category. We can say one is called parallel twin stir friction stir welding process, another one is called tandem twin stir friction stir welding process, and another one is called just here you see staggered twin stir friction stir welding process. This first one is called parallel FSW. In this technique here in first figure I have shown, this is generally parallel twin stir friction stir welding process or twin stir technique. Here 2 tool we use, this is one tool, this is another tool. Here you can see this tool is rotated, one is rotated clockwise, another one is anti-clockwise rotated, and this is the generally this is the workpiece, this is the workpiece. So, this is the top view actually, this is the welding direction, this is the welding direction. So, in this direction here generally this welding is done. Okay. Now, this is called twin stir friction stir welding process. These techniques overcome the problem of plate thinning. Generally what happens, whatever the chance of plate thinning types of effect is there, that generally we can overcome by using twin stir friction stir welding process. Now, tandem twin stir friction stir welding process, this tandem twin stir friction stir welding process is like here generally two FSW tool generally is placed simultaneously one after another. So, that means this is one FSW tool, this is another FSW tool. What I am telling you is, so one is rotating clockwise, another is rotating let us say anti-clockwise direction. So, this tool is passing in same line simultaneously. This you should keep it in mind. So, this is called tandem twin stir FSW process. So, tandem twin stir FSW process, it is a twin stir tandem is a contra rotating FSW. Contra rotating means oppositely rotating 2 FSW tool are there. Okay. These techniques improve the weld integrity by fragmenting and dispersion of residual oxide remaining within the first weld region by the following tool, that means by the second tool. This is the first tool. So, due to this first tool, after that whatever the residue or you can say residual oxide will remain, that oxide generally fragmentation of that oxide is taken place by this second tool, and what happens, it is also dispersed. So, what happens, it improves the weld quality. As the tool orientation means that one of the tool follows the other, the second tool travels through the already softening material. This means that the second tool need not to be reversed. So, this second tool need not to be reversed, because due to this first tool this material already becoming soft enough. So, that is why this second tool does not require a robust types of material, because it is passed through a soft types of zone. Now, use of this friction preheating tool may help minimize probe wear on the following tool. So, this second tool probe wear we can reduce significantly. Now, staggered twin stir friction stir welding process, this is staggered twin stir friction stir welding process. Here you see in this process generally tool is used in such a way, it means that an exceptionally wide weld region can be created here. So, here essentially the tools are positioned with one in front and slightly to the side of the other, so that the second probe partially overlap the previous weld region. Here you see this is the probe region and this is the, so you see this tool is partially overlap. This you see, this is one welding zone, this is one welding zone and this is another welding zone. Here you see. So, these two welding zone partially overlapped each other, as you can partially overlapped is taken place. This arrangement is especially useful for lap weld. This you should keep it in mind. As the weld is wide in case of lap joint, then what happens, as the wide weld region provide greater strength than a single pass weld. This also, because in lap joint wider the weld region, greater will be the strength. This you should keep it in mind. And what happens in this partially overlapping region, if there will be any residual oxide, that can be fragmented and dispersed by this second tool. Okay. These two tools also have two oppositely rotated tool, you see, you can observe here. So, as the second tool can be set to overlap the previous weld region, that is why what happens, it eliminates any plate thinning that may have occurred in fast weld. So, what happens due to this overlapping, if there in this overlapping zone, if there is any plate thinning types of phenomena is taken place, that can be overcome by this second weld, or you can say second FSW tool. Now, this is the last category which I am going to discuss today about FSW. This is called stationary solder friction stir welding process. In this process, that probe is rotated and which is protrudes through a hole in a stationary solder. In this FSW process, that means a stationary solder friction stir welding process, here let this is the tool pin and this is the solder, this is the solder. Now, you see this tool pin, this is the tool pin which is protruded through a stationary holder. This solder is a stationary, this you should keep it in mind, solder is stationary. Only this tool pin, this pin is rotated here, this you should keep it in. That is why it is called a stationary solder friction stir welding process. This stationary solder add no heat to the surface, okay, because this is a stationary, it is not provided any heat to the surface, it is only support this what is called tool pin, you can say. So, all the heat is provided by the probe and the weld is made with any essentially linear heat input profile. What happens as this solder does not create any heat, you can say, that is why what happens, whatever the weld zone here created, it generally this weld zone is depends on this tool pin size. That is why here I have written it is generally here this linear heat input profile we can get, because you see this is tool solder, okay. So, due to this tool pin this weld zone is created. So, more uniform heating or weld profile you can get through the thickness. These types of welding techniques is popular for a material which have generally high softening temperature and low thermal conductivity, where generally like titanium types of material, this is highly essential, these types of welding techniques. They generally titanium have very high softening temperature, but low thermal conductivity. Due to this low thermal conductivity, what happens, and high melting point, this on this thermal conductivity will be less, then heat dissipation, that means heat conduction time will be more, what I am telling, understand. So, what happens to localize heating of this titanium alloy and rapid heating of titanium alloy, generally this stationary solder friction stir welding once we use, then what happens, there will be localized heating. This means that the difficulty to generate sufficient heat to soften the material without causing local overheating. To overcome this problem in titanium, this FSW is widely used. I have already told you FSW have several advantages, because friction stir welding is a solid state welding process. Here the material does not melted, so melting related any types of defects here is eliminated, like here no arc is there, no porosity is there, okay. And what happens, it has low distortion and it has low shrinkage. It can be operated in all the position. It is highly energy efficient process. It has very good mechanical property such as fatigue property, tensile property, and its bend test property also good. It eliminates consumable which is required in most of the fusion welding process, but here we can eliminate this consumable. We can use this thing both similar and dissimilar types of material. It generally simplifies dissimilar alloy welding process. It also reduces the health hazard, like what happens here, there is no toxic fume, there is no ultraviolet types of ray, that is why what happens, it reduces the health hazard also. There are few disadvantages of this welding process, like what happens, here work must be rigidly clamped, keyhole at the end of each weld is there, that you can see, because exit hole is there, cannot make a joint with which require metal deposition, because where some metal deposition types of thing is required, that is very difficult to weld by using this welding process. Initial cost of this machine generally little bit higher than some other fusion welding process. It have huge application. It is used in shipbuilding industry, offshore industry, aerospace industry, automotive industry, railway, robotics, personal computer, similar and dissimilar types of material also it has different types of available. Nowadays also lot of research work is going on in FSW process. Nowadays some work related to 3D printing related thing also generally implemented this FSW process. Apart from this thing, this FSW process also have application in surfacing purpose, surface cladding types of operation purpose, also this FSW process is nowadays applied. Okay. So, these are the references which I have followed for making this lecture. Thank you.